In this short video, we're going to see how we can redirect the output of the printf function through an UART channel and display it on a PC terminal. We start by creating a new Renesas C++ project and name it print_UART. On the device selection menu, we shall choose the board EK RA6M4. We keep the rest of the configurations at their default choice. For project template, we will choose the bare metal minimal option. Once we click Finish, the project files will be initialized. Our first task would be to add the necessary stack for UART communication. We can find this in the Stacks tab. From the New Stack menu, we need to find the UART communication stack called r_sci_UART. This stack shall allow us to configure a single UART channel. This stack needs to be configured for a selected UART channel. To see which channels are available and what pins can be assigned, we navigate to the Pins tab. In this window, we can see the available serial communication interfaces. From this list, we can see that channel 4 is not assigned to any operation, so we can enable the asynchronous UART mode for it. We notice that the pin 207 and pin 206 have been assigned by default to this channel for transmission and reception. If required, we can change the transmission and reception channel to other available pins. For this project, we can keep it as it is. Now, going back to the Stacks tab, we can designate channel 4 to this stack, which is named G_UART0. We can also change the baud rate in these options. We choose 9600 for our channel. For rest of the configuration, we can keep them at their default values. For this application, we would also like to have a callback function attached to the interrupt. We name the function UART_CB. Once that is done, we can generate the project contents, which is the necessary files required for implementing this configuration. As the configuration files are created, we can then move on to writing our code. We shall have to write the application code in the hallentry.c file in the source folder. As we are working with the printf function, we will need to add the standard input-output library through the stdio.h file. Then, we need to create the global flag variable for the UART transmission status and set the value to false. Next, we shall redefine the puts function. This will essentially redirect the printf implementation to our preferred transmission channel. The first line of the function will set the transmission status to false. We will also initialize a status variable to hold the return status of any FSP-specific implementation we will soon see. The next few lines will format the template transmission data and get the length using sprintf function. Then, we will call in the function to transmit data over UART channel. This can be found in the Developers Assistance tab and has already been modified based on the stack configuration. This function returns the status of the function call. Two arguments are required for this function: the source of the data and the length of the data in bytes. We then implement an assert macro to make sure the previous function call has been successfully implemented. To end the puts function, we create a return statement. The template for the callback function definition associated with the UART stack can be found in the Developers Assistance menu. We shall include that in our code next. In the callback function, we will use a simple if statement to check for the event status of the UART channel. If the event has been completed, we shall set the transmission flag to true. In the hall entry function, which is the function that runs in the main function, we shall also declare a status variable. Next, we will include the function call for opening the UART channel. This is also available at the Developers Assistance menu. An assert macro is included here as well to verify the open channel function return. We will then create a while loop that runs indefinitely for the rest of the program. In this loop, we will use the printf function to print a string. Because we have modified the puts function before, we expect this string to be printed in our PC terminal. We will add a software delay to add interval between the print statements. Then we can build and debug the program. The EK RA6M4 board needs to be connected to the computer via a USB to UART adapter interface, which is easily obtained off the shelf. The adapter has transmission and reception pins as well as power and ground pins. Once the program is uploaded to the board, we need to open a serial terminal emulator such as TerraTerm. We choose the right port, which refers to the connected adapter, and the data that is transmitted from the board via printf can now be seen on the terminal screen. And that is how we can create a printf implementation that output data on a PC terminal from an array board.